Okay, this is page 341, sequences. This is 8.1, and this comes with a boredom alert. Please do not adjust your set. Sequences are not very exciting. In fact, they're a little bit confusing. We'll see if we can roll through some of this and give you a general idea. First of all, a sequence is typically written like this, and it's just a bunch of numbers. Here's the sequence where we add 2, and then we add 3, and then we add 4, or 10, there, 15, 21, dot, dot, dot. What I just written there for you is what's called an infinite sequence. The dot, dot, dot just means it keeps going. You can recognize the pattern here. There's a span of 2, and then there's a span of 3, and a span of 4, a span of 5, span of 6. And then the next number would be 28. That's a span of 7, and the next number would be 36, and so on forever. So this is a sequence of numbers, and a sequence, let's just write this down, a sequence. That's a sequence. It is made up of terms. Terms. So there's the term number 1, term number 2, term number 3, term 4, term 5, term 6, all the way to, well, any term in here would be called the nth term. So each term has a position. And you can designate the position by what's called a subscript. Now, subscript, you will know from word processing, is a little number that sits below. So this sequence here might be described as sequence A, and it's made up of n terms. Well, in this case it's infinite with a dot, 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 but if it wasn't an infinite sequence, if it was just, say, these 6 numbers, then n would be 6, and there would be 6 terms in total. So this is a sequence here. That's a sequence of n terms. And it's designated that way, or it's titled that way, and it could be A, it could be B, it could be Q, it doesn't matter. Any variable works there. So what mathematicians like to do in their continuous attempts to terrorize their students is they like to write things down like this. AN, or the nth term of sequence A, is equal to some kind of a formula. So it's starting to look a little bit like a function. In fact, a sequence is a function, but it's because it's a series of numbers, of discrete numbers, as opposed to like a linear function that's a continuous line. Because it's a series of individual numbers, it's called a sequence instead. So n plus 1 over n. So if that was the formula for sequence A, and we wanted to know the nth term, it would be n plus 1 over n. So if we wanted to know the 6th term, let's say we want to, let's write this down this way. Then the nth term is n plus 1 over n. So say the 6th term, that's as a for instance, the 6th term is 6 plus 1 over 6. Because 6 is what we have for n, so 6 plus 1 over 6 equals 7 over 6, and that would be the 6th term of the sequence. Now this is useful in a lot of areas. It's useful in finance and in biology and economics and computer programming, in politics, in marketing, all kinds of areas where you have sequences of numbers and you need to predict or you need to calculate what the nth value will be. Give you a quick example. If I've got a bacterium or some kind of an infection and it grows at a certain rate and I know what that rate is, the rate per hour or per day, and I want to know how many microbes am I going to have after 24 days, for instance, knowing the function and knowing how the sequence works, and I can calculate the nth term would be important. So, an example from finance, once again, if I was saving $100 per month and I wanted to determine after I don't know, let's say I have an interest rate as well, an interest rate of 10% per year, and I want to determine after 25 years how much money would I have. That would be a calculation of the sequence as well. So A1 is the first term of a sequence. Well, of sequence A. Now, here's where the book gets tricky. It explains something called recursion on page 341. If I write A1 equals 3, in other words, the first term of the sequence is 3, comma, AN equals AN minus 1 over N. It's a little bit complicated. A to N minus 1 over N, which means that if N was, say, 8, then N minus 1 would be A7. So if A8 would be A7 over 8. That's kind of complicated. So this series would start, or sorry, this sequence would look like this. The first term is a 3, and then it goes on for a while, and we don't know what the rest of these are. But I can figure out A2, because A2 equals A 2 minus 1, so A1 over 2, which equals 3 over 2. So the second term in the sequence is 3 over 2. A3 equals A2 over 3. Now A2, as we figured out, was 3 over 2, so that's 3 over 2 over 3, which equals 1 over 2. So the third term in the sequence is 1 over 2. Now you can see here that we're using n in the definition of an, which is why it's called recursion. It's kind of circular. A4 equals A3 over 4. And that equals, well, A3 was 1 over 2, 1 over 2 over 4, which equals 1 over 8. A5, this is the last one we're going to do, promise, remember. A5 equals A4 over 5, which equals 1 over 8 over 5, which equals 1 over 40, and on it goes. So you can see that the numbers are going to get progressively smaller as we get through the sequence, and what we're doing is we're using the number from before to calculate the next number each time. So that's called a recursive sequence, and I don't believe the book goes much further than that with recursive sequences. There is an exercise on recursive sequences, exercise 4 on page 345. Exercise 4, page 345, if you'd like to practice with that.